basically developed a reader for that. So, JT. Okay, so JT is a very new, it's even newer than Sept. It's a very new file format that's been proposed and is now being accepted as a standard. The thing that's nice about JT format is it has at least 3 representations to it. It has a very low-level kind of tessellated representation. It has kind of a mid-range mathematical surface representation, and then it has kind of a very refined, very accurate representation. So at the lowest level, the JT format is very lightweight and very viewable inside of PLM systems, inside of the web. Okay? If you want more to bore down on it and get more detail and more refined, it carries with it the mathematical information that it can refine the model and give you very accurate, very precise manufacturing data. We're quickly running out of time. So now we're going to talk for just a few minutes about the kernels. So here's the Parasolid kernel is viewed, I think, worldwide as kind of the #1 kernel that's out there. You can actually click on that web link that's a Siemens link and learn all about its capability, where it's used, what packages it's used in. The ASUS kernel, which is owned by Dassault, it was purchased by Dassault just a few years ago. And the reason they purchased it was because Siemens was going out and saying, well, we have a kernel that you can write to and develop and work on and everything else. And so kind of picked that up so that they could claim to have a published kernel. They don't, so does not want to publish their CATIA kernel. They feel that that is too proprietary, too much of the corporate jewels are in their CATIA kernel. So they purchased this one as a way to kind of say, well, we've got a kernel too. Now that kernel doesn't interface with CATIA. GSNlib and TSNlib, as I mentioned, are things that you find a lot in universities as kind of the grassroots or the basis that they build their research code on. So the question is, when should you use a kernel to do the translation? Whenever the receiving system has the exact same kernel, right? So if you're going from Parasolids, excuse me, if you're going from NX to, say, SolidWorks, you would want to go through the Parasolid kernel because most of the data is going to go there. If you went through IGES, is the data going to go there very well? If you went through STEP, is it going to go there very well? Not as well as kernel to kernel. Okay? So there's kind of a pecking order that you want to think about. Well, if something is lost in the kernel translation, what is lost? Does the history tree inside of SolidWorks or inside of Solid Edge look exactly like the history tree inside of NX? It doesn't, and so that has been somehow layered on top of the kernel, and so some of that history information and things like that will go away. Will the geometry be perfectly exact? Will it have the same things? Yes, it will, because it's kernel to kernel. Okay? So anything that the graphics system layers on top of the kernel, that may go away. So what's retained? The stuff that's native to the kernel. What is lost? Well, if it has layering or if it has viewing or anything like that that's been added on top, that's going to be lost.
So are like the parameters and the alpha dimensions part of the, I guess, inside the kernel, they would be transferred or not necessarily?
So the parameters are more than likely part of the kernel. The actual precise dimensioning that you do inside of drafting, that is different. You know, but if you're putting length, width, and height as parameters on top of graphics, you know, then that's going to go and be retained. Are there accuracy issues? No, there's not. What about accuracy in the remodeling or in the neutral file exchange? Is there an accuracy issue potentially? Yeah, remodeling could be really ugly accuracy-wise. And the accuracy of the neutral file format, it does have and will have some potential for round-off problems. I think we'll stop there and pick up on direct translation next time.